This conference will now be recorded.
Hello, everybody. Hope you're doing well. This is Jordan Girth from the National Weather Service Office of Observations, bringing you another Satellite Book Club seminar. This is part of a series. It's session number 37. We have a great presentation today from Joanne Culin and Daniel Lamb of the Jackson Weather Forecast Office, as well as a presentation that was given at AMS. I found very interesting and look forward to hearing more today. Our facilitator is Darren Van Cleve of the Science and Operations Officer at the Salt Lake City, Utah Weather Forecast Office. The title of the presentation is Utilization of Satellite Data to Enhance Storm Damage Assessments. Just a few reminders, as you heard, the session is being recorded and we will have an opportunity for question and answer after the presentation if you can stay on. Please post your questions in the chat room and we will field them in the order they were asked, and Darren will be facilitating that. We're always looking for future presenters, so if you have a unique application that would benefit our field offices, please feel free to get in touch with us. We'd love to have you in a future book club seminar. Training team can help you create training materials or find training materials that may be unavailable or you're unaware of. Brian Mata, the Office of the Chief Learning Officer, can help you with that. Just like to thank our Tower S team, particularly Kashad Bowman, the Office of the Chief Learning Officer, and the GOZAR and JPSS programs for their support of the Satellite Book Club. Without further ado, I'd like to introduce Joanne Culin, a Senior Meteorologist at the National Weather Service in Jackson, Mississippi. She received her Bachelor of Science degree from Texas A&M University and Master's degree at Florida State. Been with the Weather Service for 18 years, 14 of which in Jackson. She enjoys greatly working directly with local officials and partners to prepare their communities for impactful weather. And Daniel Lamb joining her today is a meteorologist at the National Weather Service in Jackson, where he's worked since 2010, and he began his career with the Weather Service in 2006, focusing at the office in radar, climate, and working with students. So Joanne and Daniel, welcome to the Satellite Book Club.
Thank you. Good morning or afternoon, everyone, depending on which time zone that you're in. And hello from cold and very icy Jackson, Mississippi. It's been a pretty interesting week for us here. You know, in the South, we don't get a lot of winter weather, or it doesn't linger for very long, but we've had quite a few events here in just the last week. So we're going to switch gears a little bit to talking about using satellite data for storm damage enhancements for mainly tornado surveys. So, all right, so in the National Weather Service, as many of you probably know, we use damage assessments to go out and look at storm damage following severe thunderstorms and possible tornadoes. And over the last 20 or so years, these advancements have streamlined the process greatly. Some of the advancements include the development of the damage assessment toolkit, which has allowed us to, it's kind of given us a guide with predetermined damage indicators to help with deciding a proper tornado rating, and then plot the storm damage while we're out in the field. The data collected in the DAT can also be seen in the office, and you can coordinate assessment efforts and produce damage maps for partners, social media, etc. And the second big advancement in storm surveying is dual polarization radar and identifying tornado debris signatures. And using this information, we can plot damage path polygons on a map or in the DAT to use in the field for surveying damage. And this helps us identify locations to target and conduct our surveys more efficiently. Even with these advancements, there do still exist challenges with ground surveying, and probably some of the biggest challenges that we encounter is the lack of roads to travel down between damage points or access to these road networks for whatever reason, whether they're blocked off or has been the case this past spring, and other times they're flooded, so you just can't get down these roads. So kind of to supplement this information, using satellite data has shown us that it's a big help with surveying tornado damage, not necessarily immediately after, but even a week later. So this past spring, we actually satellite data from the Sentinel-2 satellite. And this is a constellation of 2 polar orbiting satellites placed in sun-synchronous orbit, and they're phased about 180 degrees from each other. And the goal of this satellite is to monitor variability of land conditions. Now there are, due to its wide swath and high revisit time, it monitors the surface, so you can monitor how things are before or after. Bands that it uses, and the resolution is dependent on which one it uses. The resolution itself isn't necessarily good enough or helpful enough to see individual down trees or very specific for that information, but it's good to see swaths of damage. And you can determine tornado track lengths from that. And this data is available on a regular basis and updates pretty frequently. So where can we find this information? It can be viewed or downloaded using the Sentinel Hub website, which is the website is located on the screen. It has a viewer allowing you to select different locations, dates, and products, such as bands and band combinations or composites. You can create an account that allows you to download bands or combinations in image formats that we typically would use, like JPEG or PNG, and geo-referenced image formats, TIFF, or a GIS format. And then you can take the selected imagery and it can be viewed directly in the DAT software that we use. So taking a look at some of the techniques that we used, and I'm going to kind of go through a little bit of this, but after my presentation, Daniel's going to show how we utilize this data. We used a couple of composite images. One was the True Color, which is a combination of visible bands that create a natural color product. The other was NDVI, which is a normalized difference vegetation index that highlights areas of green vegetation. Now, this is especially useful when differentiating dead vegetation and damaged swaths. You can view the potential changes in landscaping using these single satellite images, but it really stands out when you're using image differencing, which is kind of what we're going to be talking about in this presentation. And to accomplish this, we downloaded imagery from the Sentinel website before and after a tornado event, which can sometimes be a challenge, of course, because you want to make sure that you have a clear weather day to get those images. So it may not be readily accessible right after an event. But we then used GIS software to create difference images. Users can then export the difference images as a GeoTIFF, load into Google Earth. You can draw polygons around the damaged swath that highlights this difference. Import that into the DAT to view it over some of the ground survey damage points you have for comparison. So here are just a few of the events that we used primarily in April of 2020 across our forecast area. The first one is a tornado that began in Louisiana in Avoyelles Parish and crossed into many times Catahoula and Concordia parishes. It was quite a complex survey just from the landscape of that area of Louisiana in itself. Now, this storm had a history of producing tornadoes. It had a tornado debris signature that was apparent on radar, so we already knew that there would be a tornado in that area. And this storm tracked across a pretty rural location that included a river, a national wildlife refuge, and very limited road access. And to make it a little more complicated, it also crossed a county warning area border that we have with the Weather Service office in Lake Charles. So this required quite a bit of coordination on both of our parts with regard to the track. Reports of the damage were received from the storm, and we sent survey crews from both offices were sent to confirm those reports on both ends of the track. But we did have some flooded roads and inaccessible roads in the wildlife refuge. So there was about a 5-mile area where survey crews couldn't physically get to. And this is highlighted in the bottom left picture with a big question mark. What was going on in that area? We weren't entirely sure. So we didn't have any other reason to believe otherwise, so we just assumed it was one continuous track. However, when we started using the Sentinel data and making those difference images, we investigated the area and compared the vegetation before the tornado event and then again after. It was noted that there were actually two separate swaths of damage, and these are highlighted by the white outlined areas on the image. And imagine our excitement to see this, how we could use this information. Because otherwise we would have had one long tornado, but now that we see that there was presumably two paths there. So we use the swath information to put it into GIS and then overlay it with the survey from the ground survey. As you see on the image here, the gray area, the swath area, is the information from the Sentinel data, and then the triangles and the line were the damage survey indicators from the ground survey and the presumed single track. And from here, we were able to split them into two separate damage paths and fill in the gaps where the road networks wouldn't allow us to actually get to in our cars. So the next example was from the Easter tornado outbreak in 2020, and was a tornado that occurred in the Delta National Forest, which is in the northwest to north central part of Mississippi. There was a well-defined tornado debris signature with a storm that lasted for 10 minutes. And because of this, confidence was pretty high that there was a tornado, but it occurred over a national forest. So you can imagine we don't get a lot of ground truth reports out of that area. And it crossed, it didn't cross any year-round public roadways either. So what were we gonna do with this information? We did send a survey team to the area to assess the damage, but they didn't find any damage on the two roadways that were made highways that crossed the mesopath. And while that area of the Delta National Forest had roads, they were inaccessible once again, because we're talking about the spring here, due to seasonal backwater flooding, which is outlined in the MODIS imagery as the area that was flooded. So this would not be quick to subside. So the most timely solution was to use aerial imagery to confirm the tornado. So by looking at before and after satellite imagery, there was confirmation of a tornado, which we also knew from the tornado debris signature, but there was still some question as to how long the path length was. And it was rated pretty conservatively based on the EF scale and tree damage indicator options, knowing, generally speaking, you know, what kind of trees would be in that area. So once again, we created this difference image, and that really highlighted the area of damage. It resulted in further confirmation of the tornado, but also the length of the path. Without actually getting to go into the area to survey, we weren't sure exactly how long the path length was. So using the satellite information, we were able to make some adjustments for that as well. And then finally, this technique was used even for a tornado path that was well surveyed and it was very well defined. This was during another tornado event last April in Marion County, Mississippi, which is kind of in the southeast part of the state. There was a clear damage path with sufficient road access for most of the survey area, but there was one primary area that was difficult to access when the tornado crossed the Pearl River, and we couldn't see the damage in this location. As you can see, the damage path was very evident in the different image on the top there, related to the tornado and continuous over the inaccessible location. And so we used the satellite imagery to help fill the gaps where the roads we weren't able to access. And it also helped a little bit of information with path width. But you can see on the bottom image there that there was a definite gap in areas that we could actually do a ground survey. So it did help kind of fill in the gaps there. So just looking at some thoughts on aerial imagery and tornado ratings, as you might expect, the ability to rate tornadoes is quite limited using aerial imagery. So ground surveys are still vitally important to rating tornadoes, and so this should really be supplemented for that. Few damage indicators can accurately be accessed from without these ground surveys. Tree damage is primarily what you can probably see from satellite imagery, and the degree of damage indicators for trees are based more on tree type rather than extent of damage when using this. Not all tornadoes are going to be apparent using satellite data or image differencing, and this is going to be especially maybe not as helpful in areas with limited tree cover. But damage paths at this point we're seeing are more likely to be seen or noticed around an EF1 or EF2 range, but it's also possible that you could see portions of a lower end tornado path. It just really depends on the land use of the area of the tornado path. So in summary, we used the satellite to imagery to help confirm or identify the occurrence of tornadoes in several events back last April for our forecast area. The composite imagery and image differencing allowed for higher confidence and easier detection of tornado tracks, especially where those road networks were inaccessible. And we supplemented ground surveys and we refined that tornado information for these. And we think that this is something that could be very useful in supplementing ground surveys and add more value and clarity to just one of the many things we use for the survey process. Again, it doesn't provide enough detail to be used alone, but it's useful in completing the picture of the entire tornado event. So that's our contact information, myself and Daniel's, but I am going to hand it over to Daniel so that he can provide a little bit of a demonstration.
All right, thank you, Joanne. So just quickly, I was going to kind of show you the way that we use the Sentinel website when we're doing this. She had the link earlier in the presentation, but you can also just do a search for Sentinel Hub EO browser, and that should take you right to it. Now, this website, there are some options for different paid accounts, but you can sign up for a free account and you have access to all the features that you would need to download this imagery. So you get that login. It's a trial and it actually expires after a month, but even after that, your login will still work and you'll still have access to everything. So you go to your EO browser. You would of course want to move the map to the area where you want to be. And the easiest way to get into this is don't worry too much about the details. Go ahead and do a search. And then just visualize the first thing that pops up, and that kind of gets you to the screen where you can, in my opinion at least, more easily navigate to what you want to do. So once you get to this screen where you have the date option at the top, if you click on it, it'll give you a calendar, and what's nice is based on where your map is, it will highlight the dates where there's imagery for that location. So I like to kind of skip over to this. You can also see that they have several predefined composite image options that you can choose from. Again, Joanne mentioned before, we primarily use the True Color and the NDVI, but you can test out any of them, or you can look at individual bands. You know, a lot of what we've done is just kind of experimenting in different scenarios. You know, different options work better in those cases, just depending on what's going on. So I'll switch over to this other tab. An example from recent was this EF3 tornado that happened in Fultondale, Alabama, just to the north of Birmingham. And so we generated, we downloaded imagery and generated some difference images for this. And so this is kind of an example. This tornado occurred on January 25th. So looking at your calendar options, the first pass was actually the day before, and we happened to luck out and it was a cloud-free pass. So that's a good thing because you're getting a much better idea of what things were like just before. Now, after was a little bit trickier. There were several days in a row where there were clouds, either full cloud cover or partial cloud cover, and it was really limiting things. And I kept checking the website, waiting for a good clear day afterwards. It was getting a little frustrating. This happens a lot, and an issue that we've run into as well is during the cool season, you know, there's not as much live vegetation, so that can also mess things up as well. But let's see here. We finally got to a good day. I believe it might have been February the 3rd. It can take a second to load sometimes, but yeah, there we go. So let's say you've found your before and after times. All you have to do, there's a little image download button on the right side of the screen. You just click on that. For the purposes of what we're doing, we don't want to just like download a JPEG. We need an image that's georeferenced. So they have this analytical tab, and you can choose a TIFF image, and these are georeferenced TIFF images. And why that's important is you can load it into GIS software. And then we chose the highest image resolution so we could get the best possible idea. Since I'm looking at true color imagery, it went ahead and checked that, but you could check off some of the different predefined composite options. You could choose individual bands as well if you want to, and download those. And so you would do this for the date after and the date before your tornado that you want to compare. And then you can take that over to your GIS software of choice. I don't have any formal training in GIS. I'm kind of the type of guy that tinkers with things until, you know, he makes it work the way he wants it to. So I've used QGIS because it's free and it's open source, a lot easier for me to get at home. That's just what I'm comfortable with. I know a lot more people use ArcGIS. You can do the same thing with that. So just initially, what's nice about this is you can very quickly compare before and after by just checking on and off layers. And you can very clearly see before and after where the tornado track is there. This is using the true color imagery. And then I also downloaded the NDVI. And you can similarly see, it's not quite as clear in this case because this is more of an urban area, so there is some vegetation, but not as much. Also, we're in the cool season, so things aren't growing quite as much. But basically, you just use the raster calculator. I'm not going to go through all the details of that, but talk to your office's resident GIS expert, and I'm sure they know how to use raster calculation, and that's how we get the difference images. And so this is the difference image we generated from the true color image. And then similarly, this is the one from the NDVI. And you can see certainly some of the beefier parts of the tornado track stand out very well. So one other thing to mention before we toss things back over for questions, how do we actually get this into our surveys? One of the things we've done in the past is we would save off these georeferenced TIFF images. And since we couldn't load them directly into the DAT software, we would load them into Google Earth because Google Earth will let us draw a polygon and save it off as a KML, and that we could upload into the DAT. But more recently, we're kind of working with Southern Region and working with some of the DAT folks, and we're going to see if maybe there's a better way that we can just get these actual images into the DAT. This is much more direct. It would make it a lot easier for us to actually work with it for our surveys more directly. So that's pretty much all we have, I guess. So I'll toss it back over, and if there are any questions, we'll be happy to try our best.
Okay, thank you so much, Joanne and Daniel. Once again, I'm Darren Van Cleve, and I'll be your facilitator for this portion. I'd like to encourage all of our audience here to stay on for the discussion and also to complete the feedback survey. It's going to be posted in our chat room. And I will also like to mention that just before we get started on questions, just a teaser, 1 week, Lee, who's on this, will introduce the AWIPS Cloud Reach and the future plans associated with that. And more information will follow in an email from the Towers S team. And the other information for that is up there on the screen, including how to to contact both Lee and Kashad with that team. And with this point, I'd like to remind our attendees they can submit their questions in the chat, or they can indicate it in the chat if they would like to unmute themselves and use audio. So with that, I think we'll go ahead and dive right into our questions that we have here. Looks like we have a few in there now. So this is a question for both Joanne and Daniel. Scott Lindstrom asks, does MODIS or even VIIRS false color imagery or NDVI changes, do those corroborate the Sentinel data, or are there some resolution limitations that are preventing you from using MODIS or VIIRS?
So one of the things that that we like the most about this, that has made this so helpful to us, is so the resolution isn't necessarily the very best, but this updates regularly and it's available across our entire area. So we've always had other options for satellite imagery and trying to look at this type of thing. But in terms of, I think accessibility is kind of the biggest factor that really draws us to this, and timeliness. We know, we're going to have new imagery. Now there may be cloud cover and we might have to wait again, but pretty much every 3 to 4 days there are going to be new images. And it's not a convoluted process. We don't have to specially request it. It's waiting for us at this website. Some of the other satellite imagery, that's probably also the case with that. But this, I don't know, this is just what we discovered as we were going through this past severe weather season. And Joanne was talking a little bit about resolution, and I don't know how it compares to the other satellites that were asked about. This is fairly high resolution. Again, it's not going to get us down to like individual trees, but it's high enough resolution that we can see a damaged swath. So the biggest draw for us, with this versus other things we've looked at, and certainly, we're not satellite experts, so that's not to say that there aren't other options out there. But what we've liked the most about this is just the simplicity of being able to go to this website that's publicly accessible. We don't have to request anything. Imagery is there, imagery is there going back years. So it's just very easy to access this data and to utilize it.
Thanks. And I saw a question that just came in. If somebody was asking if you could repeat how you got to the EO browser website.
Yeah, certainly. I was just saying you can just do a Google search for Sentinel Hub EO browser, and that should take you right to it. The URL is apps.sentinel-hub.com/EO-browser. So
I actually had one quick quick comment to add here, Daniel. For our weather service folks that are on the webinar here, these geotiff files that you were downloading from this website, those can actually be imported into AWIPS quite easily. There's an option in AWIPS to import files, and you can import a geotiff right in, and it works natively in that environment as well. So if you wanted to see it in some place other than in a GIS based program. So one other question here. So there was somebody asking, can we, with this EO browser site, are there any restrictions on making free accounts that you're aware of? Can we do so with our the emails?
We're unaware.
when you guys set up yours, were you using your work email?
Yeah, so admittedly, initially, I was probably pretty reckless about this and just did it without asking anyone. But my impression is there aren't any restrictions in terms of using this data. It might get a little bit more convoluted if you're trying to use the imagery. You definitely would want to attribute it, but mainly we've been using this internally and not for sharing with the outside world, but just internally to be able to make these determinations. And in terms of doing that, my impression is that there are no issues with that.
Okay, and it sounds like you already answered part of the other question there, which is, is this stuff that can be shared outside? And it sounds like just based on the use case that you have here, it's just an internal only type of a tool at the moment.
Yeah, I mean, and it may be fine for sharing outside. That's definitely something you would want to look into more before you started doing that, though, because the way we've been utilizing it so far is pretty much strictly internal.
So one other kind of a quick question that I had for both of you is how small of a tornado do you think that you could detect with this?
Oh, go ahead.
No, I was just about to say, if one of you were talking, you must have been muted.
No, so what we've seen so far is it's really just been like the EF1, EF2 range that we've seen it. There have been some portions of, smaller rated or lower rated tornadoes that have been apparent, but it's kind of been in that EF1, EF2 type of range.
Okay, thanks. There's
One
been
thing I would add.
Oh, sorry.
One more thing I would add to that answer is it's probably driven more by the width of the tornado than the intensity of the tornado. And since, weaker tornadoes can be wider and stronger tornadoes can be more narrow, it really just depends. And then we've also had some stronger tornadoes that have gone through fields, and this is not helpful with that. We actually, we had a really big EF4 tornado, the Bassfield tornado last year, that it went through a field and left kind of a path through the field. This data is not really resolute enough to see that type of thing. So really it just kind of depends on several factors, including what kind of land use exists and kind of width of the tornado and that type of thing.
So I'm glad, Daniel, that you touched on that last point, because that was actually another follow-up question I had, which is if you had tried this in any areas with a different type of land surface cover other than kind of the thick trees, which seem to be most of your use cases from those 3 or 4 examples I saw.
Yeah, it's definitely more challenging in the areas with fewer trees. Much of the northwestern part of our forecast area is what we call the Mississippi Delta, and it's pretty much farmland for the most part in the areas, the kind of the flatter areas near the Mississippi River, and it's also more sparsely populated. It's an area that's already difficult for us to survey, traditionally on foot and in the car, because there are less damage targets for a tornado to hit. And so we see similar issues when it comes to using the satellite data as well. Unfortunately, resolution isn't great enough to really pick up on more subtle types of damage.
Okay, so in our comment thread here, we had a follow up to one of the earlier questions, which someone chimed in to add, there are restrictions to sharing imagery with the public using the Sentinel Hub site, but the Sentinel imagery itself is free to share per an agreement between ESA and the NOAA. So thanks to the individual that left that comment. And then we had another specific question. Someone asked, for the last tornado shown with the wider black spot, does the edge start at EF1 or EF0?
That's a good question, and I do not know the answer to that off the top of my head. We had this loaded into the DAT website. I don't remember exactly how you add it. It was one of the imagery options that you could add. And so if we had that pulled up, we'd probably be able to see, but I can't remember off the top of my head exactly how this related to the actual EF rating contours.
Okay. And just looking through some of our other the other comments that have been left there. Earlier on, Scott Lindstrom left a comment that mentioned an alternative place to get imagery from this, or an alternative place to get the Sentinel imagery. We also had someone else that was advocating for not being either or between those various satellites, but trying to use everything out there. And they said JPSS can work with you to determine how quickly or how you can quickly get VIIRS imagery. And I think we're caught up with the questions that are in there. Did anybody have any audio? And we've had a few more comments in here. I see Jordan Girth left a link to some legal information about how we can use that data from this from Sentinel. And one more recent comment from Carl Jones saying that some crop damage from tornadoes in their experience has shown up nicely in the northern plains, and he left a link from a damage survey. Okay, Jordan, I think we've addressed most of what's been mentioned there in the chat thread.
Yeah, and thank you, Darren, and thank you to our presenters, Joanne and Daniel, for this presentation. It's really good to see Office being proactive to get additional satellite data available. There is other SAR data out there, but it's not necessarily free. And one of the takeaways for me in this presentation is to talk to some people in the NESDA satellite analysis branch to see what kind of resources are available for a field office to receive more SAR data if they need it. I'm just not very familiar. I know that, for example, the satellite analysis branch uses SAR data to help in like oil spill recovery and things like that, but I don't know if these services for SAR data extend to these kind of events. So you've made a great case of why and how we should be using this. In a lot of cases, there is a very clear signature here of the damage. So it's been a very busy weather week for a large part of the country today. And obviously, we're glad to hear that people in Texas are finally starting to get their power back. Thanks to all of you for joining us, taking time out of your day today. Please feel free to get in touch with our presenters if you'd like more information, or get in touch with us if you need assistance, for example, with anything that the Tower S team does as far as getting data into AWIPS. With that, I hope you'll join us again next week. I believe it is Lee Byerly. And there's a feedback survey in the chat. Until then, we'll see you next week. Take care, everybody.